Hey folks, this is Aditya, and in this lesson, we're going to solve some sequences and series exam style questions. So, I have this really interesting question in front of you, which carries total of 5 points in your IBT final exam. So, which says summation where t is equal to 1 goes up to n and opens up a bracket, and so in that there's a summation where k is equal to 1 goes up to t and a number of 0.5 to the power of k. So let's once write down the question again for getting some clarity, of course. And t is equal to 1, with the bracket, summation t. Sorry, my summation is so bad. T, where k is equal to 1 and 0.5 the power of k. So the first step would be to simplify the summation which is there inside this bracket right here. And that is a really good trick because people just go around and summing the whole equation, not the equation, but the whole problem, and they end up getting into trouble. So let's not do that. And let's first simplify the summation in the bracket. Summation t is equal to 1. And if you have to simplify this summation right here, what we need to do is get a sequence for that. Now, we know any summation can be written as a form for sequence. So where k is equal to 1, it goes up all the way to t. So let's substitute k as 1, 0 0.5, 0 0.5 square, and 0.5 square and 0 0.5 cube. Now, this is just variable k, and I've substituted them with 1, 2, and 3, and it just goes on until t. Let's write this here. And so if we just expand this, if we just expand this further, let's not expand further, but what we know from this series, from this sequence, is that it is a geometric sequence. How's the geometric sequence? Let me prove it to you. Let's consider this u1, u2, and u3. For a geometric series, there must always be a common difference denoted by r generally most of the times though. So u2 by u1 must be equal to u3 by u2, must be equal to u3 by u2, right? And here our u2 would be 0 0.5 square by 0 0.5, which would be 0 0.25 by 0 0.5, which would be 0 0.5, and u3 by let me just write this here, u3 by u2 would be 0 0.5 cube, which is 0 0.125 if I'm not wrong, and 0 0.5, sorry, 0 0.25 because u2 is 0 0.5 square, and this would ultimately prove to be 0 0.5 as well. So hence now we have proved we have a common difference, and it is a geometric sequence. So let's erase this to get some space now. And now, since we know the common difference, let's write summation in terms of a sum. Summation of n where t is equal to 1, open the bracket. Summation of geometric series. The summation of a geometric series is u1, 1 minus r to the power of n by 1 minus r, where u1 will be your first term. This will be your first term. This will be a common difference, and n is nothing but the nth term. The first term of the sequence would be 0 0.5, open this bracket, 1 minus 0 0.5, which is a common ratio, to the power of n, divided by 1 minus 0 0.5. Let's expand this. Oh my god, my summations are so bad. T is equal to 1. It goes up to n. This would be 0 0.5, this would be 0 0.5, and hence you cancel them. You'd be left with 1 minus 0 0.5 to the power 1 minus 0 0.5 to the power of n. Now, so but once we arrive to this step, I'm going to use a series property where summation, and there is a variable here. Let's take t is equal to 1, goes up to n, and it's multiplied into ak plus bk. if you expand this, you would get summation n, summation t, which goes up to n, into ak plus summation n, t is equal to 1 goes up to n times bk, times bk, right? Now this is very simple, very similar to, let's take 3 into a plus b. In order to simplify this, you have to multiply a and b both by 3. 3a plus 3b would be a simplified answer. I'm going to use the same logic over here also. I'm going to expand this summation. I'm going to expand this summation here. Summation where t is equal to 1 to n. You take, no, let's not do this actually. Let's do it again. Where t is equal to 1 goes up to n times 1 minus summation of where t is equal to 1 goes up to n, and you multiply it times 0.5 to the power of n. So I just multiplied summation with these two terms over here and put the minus symbol as it is. So to simplify this particular part, I'm going to use one more property of sequences, which would be this one. Summation where t is equal to 1 goes up to n, and you have a constant here, very important point, where c is a constant. You have full authority, or actually you must, you can write this particular part as constant times n, which I'm exactly going to do here, which would be 1 times n, which is n minus summation of where t is equal to 1 goes up to n times 0.5 to the power of n. Now, since we have gotten this, let's simplify this part also further. Let's simplify this further. N minus where t is equal to 1, 0.5 square, 0.5 cube, and it goes on like this. And this again is just the same as this, this part, just the same as this part. And what would that mean? Well, that would mean the same thing. You have a common ratio as 0.5. And since I've got the common ratio, let's do the whole thing again. Where sum is equal to u1 into 1 minus r to the power of n by 1 minus r. And if you simplify this further, you will get it as n minus 0.5, 1 minus 0.5 to the power of n by 1 minus 0.5. And this would be 0.5, 0.5 get cancelled, and what you're left over would be n minus 1 minus 0.5 to the power of n. And voila, we got our answer. N minus 1 and plus 0.5 to the power of n. Minus, just multiplied minuses with here, minus of minuses plus anyways. And this, when you start it again in a bit more clear way, your final answer would be n minus 1 plus 0.5 to the power of n. Let me just circle this. This would be your answer. All right, people. I hope if you have understood this question, and I'll meet you in the next lesson.